missile locked onto a spacecraft. To catch it, the missile doesn't aim where it will be, but it aims and follows the nose. It creates one of the most beautiful mathematical complex paths in physics, and that is none other than but the pursuit curve. As you can see in this simulation, the missile goes and targets the spacecraft, and it follows a carved path, that is the pursuit. Now, suppose you have the same scenario in your JEE Mains paper or advanced paper maybe, and there they ask after how much time will this missile hit the spacecraft. So let's dive into that. We are here back again in Physics Prism. So back here, let's articulate the particular things what we saw. We have a straight line that is being followed by the spacecraft, and there is a missile over here that is being launched, and the spacecraft is right over here. So let's suppose it has a velocity of u and the missile has a velocity of v, right? And the missile is always pointed to the spacecraft. Suppose after some time it moves there and it's always pointed there. It's moved there and it's always pointed there. Now maybe that time it was there, so it will be pointed like this. And after some time, when the spacecraft is there, the missile is here, so it will be pointed like this. It will become like a curve, right? We saw that in the animation. But now in your JEE advanced paper or in the mains paper, they can give you that after how much time t the spacecraft will be hit by the missile. So how do you do it? Go ahead, you have 5 minutes time to do this because it's a new type of problem you may be facing. So go ahead in 5 minutes, pause the video and try to solve it and write down the solution in the comments. Then come back right over here to get the solution. Well, let's start. If you look very carefully, what we have here is given the velocity u and v. We will take into account that after some distance x over here, the missile hits the spacecraft. So this distance, let's suppose, is x. Now, since we know that after t time it will be hit, so x over here, x is equals to ut, right? Now, we also know that the velocity vector that is being like this is making an angle. Let's suppose an angle with the horizontal, that is theta. So the velocity vector is v like over here, and it's making an angle like this. So its x component is v cos theta, right? So if we see over here, this small vx part over there is v cos theta, and we can do one thing, that we can break it down into dx over dt, and this dx is traveled by the missile, and that is v cos theta. We take this t to this side and then integrate. So what we will get from 0 to x, if we integrate, x is equals to v, the integration from 0 to t cos theta dt. Well, you cannot integrate directly over here cos theta because you actually don't know the function theta with respect to time, because it's a curve like this. So the theta is sometimes a straight angle like this, or sometimes a bit curved angle like this. So you don't know exactly what is the function. But don't worry, we have something else to cover it up. We will leave this over here, but we know that x is equals to u and t multiplied, right? So we will put that over there. So what we get, that we know this integral from 0 to t cos theta dt will be x over v, and x is ut, so ut over v. This is the velocity of the spacecraft times the time and divided by the missile. So that velocity ratio into the time is actually what we're getting. Now we will come to a specific point of view. Let's view this whole problem from the perspective of the missile. what we will see? We will see actually the missile is moving in a straight line, right? Close your eyes and try to imagine that. The missile is moving in a straight line to the spacecraft over here. Let's suppose the spacecraft, and here is the missile. So it is moving in a straight line, but the spacecraft is having a velocity over there. So what we need to do is we need to apply the concept of relative velocity, or you may say it approaching velocity, or whatever you say. And we know this is v, but then we need to take this velocity projection over the line of motion. So this velocity projection over here, since this is, we have assumed this to be theta, so this will also be theta. So this velocity projection will be u cos theta, right? U cos theta. Well, so what is the relative velocity? The relative velocity between them is v minus u cos theta. Well, so it's v minus u cos theta. That's very fine. No issues, right? No issues over here. Now, we will take into account the path that it travels. In the perspective of this missile, let's suppose it travels L distance. Well, one important thing that I missed from the beginning is the distance between them. Take it something like L or capital L, whatever you may find. The distance, initial position of the missile and the spacecraft is something capital L. I missed that, my apologies. Well, so let's suppose that L, small l, is the distance traveled by the missile from its perspective. So the relative velocity, whatever you say, this approaching velocity concept, dl by dt, will actually become the v minus u cos theta thing, right? Yes. So you can integrate again. Take this dt that side and integrate. So what you get is, if you integrate from 0 to L, I suppose, 0 to L dl is equals to v minus the integration. V is constant, u is also constant, so 0 to t cos theta dt, right? And guys, here we are. L is equals to v minus u times what? What? Look over here. We have already got the 0 to t integral from cos theta d theta, right? Dt. So we just put it u square t over v, and from here you can easily find out what t is, can't you? I suppose you can do that last part. Take the v, take this v that side, that is L. Well, let's take it a form. Let's give it a form, nice form, okay. Let's remove some portions from here. I'm running out of space. Well, you take this v this side, so it will be v squared minus u squared times t. Oh well, there will be a t that side. I missed that. Again, my apologies. In the integration, there will be vt. Yeah. So v squared t minus u squared t divided by v squared. So this will become what you say is L is equals to v squared minus u squared. Go that v that side, keep that t this side. So you finally get interesting thing that t is equals to L over v, sorry, LV divided by v squared minus u squared. One of the short videos I have seen that one of the teachers has asked the same problem with cat and dog, and there he gave us the question a bit different, that the velocity of the spacecraft and the missile in that case was the cat and the dog were same. But look into the fact, if the velocities of the spacecraft and the missile or the cat and the dog are the same, then they will never meet. Well, that's it. So, if you have come to this part of the video, you have really liked the video. So hit the like button and click on the subscribe button to stay tuned with such type of crazy questions. We are coming up with a series of 3 questions in a video, maybe in the next month, but stay tuned with hitting the subscribe button. Thank you.